Saturn is renowned for its magnificent and extensive ring system, a distinctive feature in our solar system. Imagine a hypothetical scenario where Earth possessed rings similar to those orbiting Saturn. Such rings would be composed of countless particles, ranging from dust to small moons, orbiting the planet. The visual impact would be profound, transforming the appearance of our sky both day and night. These rings would cast shadows on Earth's surface, altering global light patterns and climates. The presence of rings would significantly influence atmospheric conditions and orbital dynamics around Earth. Planetary rings are vast structures composed of countless small particles orbiting a central body. These particles range in size from microscopic dust grains to larger chunks of ice and rock. The rings are not solid structures, but rather a collection of individual objects. Each particle within the ring system follows its own distinct orbital path around the planet. Saturn's iconic rings are primarily composed of water ice, interspersed with some rocky material. The composition of planetary rings is determined by their origin and the materials available. If Earth had rings, their makeup would depend on how they formed. These hypothetical Earth rings could consist of rocky debris, ice, or a combination of both. Celestial rings, like those of Saturn, are a common feature around planets. One prominent theory for their formation involves the concept of the Roche limit. The Roche limit is a critical distance from a celestial body, such as a planet. Within this limit, tidal forces exerted by the larger body become immense. If a smaller object, like a moon or asteroid, crosses this boundary, it is torn apart. The shattered fragments then disperse and spread out, eventually forming planetary rings. Ring systems can form from the remnants of a destroyed moon or a collision between celestial bodies. Such events generate debris that is then captured by the planet's gravitational pull. If this debris is prevented from reaccreting into a larger body, it can settle. This settling occurs into a stable orbital plane, ultimately forming a ring system around the planet. From Earth's surface, the appearance of rings would vary significantly. Near the equator, rings would appear as a narrow, bright line across the sky. Closer to the poles, the rings would appear wider and more prominent. These rings would arc gracefully overhead, their appearance dependent on observers' latitude. Hypothetical rings would reflect sunlight, making them brightly visible during the day. These rings would also be visible at night, illuminated by the sun's light. Their brightness could potentially surpass that of the moon when fully illuminated. This celestial spectacle would drastically alter the nocturnal landscape with a persistent glow. The presence of planetary rings around Earth would significantly alter sunlight distribution. Rings would modify the amount of solar radiation reaching the planet's surface. The density and composition of these rings are critical factors in this alteration. Dense rings could block a considerable portion of incoming solar radiation. This blockage would be most pronounced in regions directly beneath the ring's shadow. A reduction in direct sunlight would lead to a general cooling effect in specific latitudes. This phenomenon has the potential to lower global temperatures across the planet. Regions constantly shaded by atmospheric rings might experience colder climates. These areas could resemble perpetual twilight zones, significantly altering local ecosystems. Planetary rings cast immense shadows onto the planet's surface. These shadows are dynamic, moving across the globe due to the planet's rotation. The orbital path of the planet also influences the movement of these vast, darkened swaths. Shadows can persist for hours or even days, depending on seasonal variations. The duration and extent of the shadows are also determined by the specific latitude. The size and density of shadows cast by a celestial body's ring system can vary significantly. A particularly dense ring system is capable of casting a profound shadow onto the planet below. This deep shadow would resemble a partial eclipse, reducing ambient light levels. Such a reduction in light would significantly impact light-dependent processes on the planet's surface. Earth's axial tilt is the primary cause of seasonal changes experienced on our planet. If Earth had rings, this axial tilt would interact with them, creating unique seasonal variations. As Earth orbits the Sun, different parts of these hypothetical rings would be illuminated. This illumination, or lack thereof, would cast shadows, leading to complex and dynamic seasonal shifts. Regions under the ring's shadow would experience prolonged periods of reduced sunlight. This reduction in sunlight could lead to colder and darker winters in affected areas. Conversely, areas outside the shadow might receive increased reflected light. This altered light distribution would significantly change seasonal patterns globally. Altered solar radiation directly influences global weather patterns. Changes in temperature gradients also significantly impact atmospheric conditions. Variations in atmospheric heating can disrupt established wind patterns. Ocean currents, vital for heat distribution, would also be affected. These disruptions lead to altered precipitation cycles and the formation of new climatic zones. The existence of a ring system presents considerable challenges for space operations. Existing satellites face significant risks from particles within such rings. Future space travel endeavors would also encounter substantial obstacles. Even small ring particles pose a formidable hazard due to their extremely high velocities. Navigating near or through orbital rings demands advanced shielding technology. Precise trajectory planning is essential to avoid potential collisions with debris. Collisions pose a significant risk, potentially damaging or destroying satellites. Such orbital operations become considerably more complex and hazardous for manned missions. Planetary rings are not permanent features over long geological timescales. These celestial structures are subject to various dynamic forces that lead to their eventual dissipation. For instance, particles within hypothetical Earth rings would experience gravitational perturbations. These perturbations arise from the gravitational influence of other celestial bodies. Frequent collisions between ring particles also contribute to their instability and dispersal. Furthermore, atmospheric drag, even from tenuous atmospheres, can cause particles to lose energy and fall. Ring particles are subjected to various forces within a planetary system. These forces cause the particles to gradually lose their orbital energy. Consequently, the particles begin to spiral inward towards the central planet. This process is scientifically termed ring rain, describing the inward descent of ring material. Ultimately, ring rain leads to the dissipation of the rings as material falls into the planet's atmosphere. The phenomenon known as ring rain involves a continuous, gentle shower of particles. These particles consist of fine dust and ice entering the upper atmosphere. This influx could potentially generate spectacular meteor showers. Over millennia, it might also contribute to atmospheric haze. Life on Earth would need to adapt to significantly altered environmental conditions. Organisms in perpetually shadowed regions would face unique evolutionary pressures. These organisms might evolve to rely on chemosynthesis for energy. This adaptation mirrors ecosystems found in deep-sea environments. Photosynthetic organisms, including plants and algae, rely on sunlight for survival and growth. Reduced sunlight poses significant challenges to these life forms. This can lead to shifts in the dominant plant species within an ecosystem. Overall ecosystem productivity may decline, particularly in shaded areas. Such environmental changes impact biodiversity and ecological balance. The presence of celestial rings would profoundly alter human civilization. Calendars would need re-evaluation, adapting to new celestial patterns. Agricultural practices would shift, influenced by altered light and shadow cycles. Architectural design would incorporate the unique visual phenomena created by the rings. The rings would become a central, defining element in human culture. They would integrate into mythology, art, and daily life, shaping societal narratives. The presence of Earth's rings would profoundly impact human culture and perception. This magnificent celestial structure would inspire new forms of art and literature. It would also stimulate significant scientific inquiry into its formation and dynamics. The constant visual presence of the rings would reshape humanity's cosmic perspective. This aesthetic and intellectual influence would fundamentally alter our place in the cosmos. Planetary systems maintain a delicate balance, crucial for environmental stability. Even seemingly simple features can have profound impacts on a planet's conditions. The presence or absence of a ring system, for example, is one such feature. A ring system can influence light, temperature, and atmospheric dynamics. These influences can trigger a cascade of environmental consequences. Ultimately, Such factors can lead to significant biological changes on a planet. The universe often illustrates the profound impact of subtle alterations. Even minor changes to a planet's structural composition can have significant effects. These small shifts can trigger a cascade of environmental and geological transformations. Such modifications can fundamentally redefine a world's climate and surface features. Ultimately, these structural changes could lead to the emergence of an entirely different planet. This highlights the delicate balance and interconnectedness within planetary systems.